2020 in collaboration with an entity called Bharatiya Shikshan Mandal. In these programs, the deliberations by the representatives of Bharatiya Shikshan Mandal focused almost exclusively on disseminating India's glorious past through the education system, the knowledge produced in ancient India that remained hidden as great treasures. Today, all the faculty members of Government General Degree College Singur feel extremely happy to organize such an event on Indian knowledge system. This particular program has been conceived and conceptualized by the IQAC Government General Degree College Singur. It is because of their relentless endeavor to make this program happen that we have been able to materialize it. May I now invite Dr. Choitali Chaudhary, Coordinator IQAC, to give a brief overview of IKAs so that our students can easily comprehend the forthcoming deliberation of Professor V. Ramanathan. Welcome, ma'am.
Thank you, Amrit. Good afternoon, everybody. It's my absolute pleasure to extend a hearty welcome to each of you present here. At the beginning, I want to thank our honorable guest and our research person, Dr. V. Ramanathan, for his gracious presence. Thank you, sir. And I would also like to thank Dr. Shantanu Chakraborty, our principal, for his constant support and encouragement in this endeavor. In Srimad Bhagavad Gita, Lord Krishna tells Arjuna that knowledge is a great purifier and liberator of the self. Actually, Indian knowledge system has accorded immense importance to knowledge. Its amazingly vast body of intellectual texts, the world's largest collection of manuscripts, thinkers and schools in different domains of knowledge. This knowledge system is also deeply rooted in Indian subcontinent's cultural and spiritual traditions, drawing from various sources, including ancient scriptures, oral traditions, and practical applications. This system is actually a profound and ancient body of knowledge, spans across various domains, including philosophy, science, mathematics, medicine, literature, and the arts. The knowledge has evolved over millennia, drawing from the country's diverse cultural and intellectual traditions. This system is not only a testament to India's rich historical legacy, but also continues to influence contemporary thought and practices worldwide. This knowledge system has several dimensions. If we consider philosophical foundation, Indian philosophy is a cornerstone of the Indian knowledge system, characterized by a diversity of thoughts and schools. Of 6 classical schools of philosophy, as we know, known as Shorodarshan, are particularly notable. Nyaya, Vaisheshika, Sankha, Yoga, Purva Mimamsa, and Vedanta. These schools explore the nature of reality, the self, and the universe, offering profound insights into metaphysics, epistemology, and ethics. If you consider scientific and mathematical contributions, Indian scholars have made significant contributions to various scientific fields. In mathematics, ancient India produced the concept of zero, the decimal system, and significant advancements in algebra and trigonometry. Here, I would like to mention a few lines by Albert Einstein. He said, I quote, "We owe a lot to the ancient Indians teaching us how to count, without which most modern scientific discoveries would have been impossible." Aryabhatta. He was an early mathematician and astronomer who accurately calculated the value of pi and the length of a solar year. Brahmagupta. He developed rules for arithmetic operations, including negative numbers and zero. Bhaskar. He made substantial contributions to calculus and algebra. In the field of astronomy, Indian scholars developed sophisticated models to describe planetary motions and eclipses. The detailed advanced knowledge of planetary system and orbits. In the field of medical knowledge, Ayurveda, the traditional system of Indian medicine, emphasizes a holistic approach to health, balancing the body, mind, and spirit. Charak Samhita and Shushrut Samhita are the foundational texts in Ayurveda. Charak Samhita focuses on internal medicines, detailing various diseases, diagnostics, and treatment. Shushrut Samhita is a foundational text in surgery, describing procedures such as cataract surgery, treatment of fractures, and so on. In the field of literary and artistic traditions, we all know that India's literary heritage is vast and includes classical languages like Sanskrit, Pali, and Tamil, which have produced an extensive corpus of literature. The Vedas, composed between 1500 BCE and 500 BCE, are the oldest sacred texts encompassing hymns, rituals, and philosophical discourses. Mahabharata and Ramayana are two great epics that blend history, mythology, and moral teachings. Indian art and architecture are equally rich, with styles and traditions varying across regions and eras. The intricate temple architecture of Dravidian style and Nagar style, the exquisite sculptures of Khajuraho, the frescoes of Ajanta and Ellora caves exemplify India's artistic achievements. The study of linguistics and grammar in India is epitomized by the work of Panini, whose Ashtadhyayi is a seminal treatise on Sanskrit grammar. Panini's systematic approach to grammar, employing rigorous rules and meta-rules, laid the foundation of modern linguistic theory. Another field was social and political thought. Indian knowledge system encompasses diverse approaches to governance and social organization. The Arthashastra by Kautilya, whose another name was Chanakya, we all know, is a seminal work on statecraft, economic policy, and military strategy, providing insights into ancient Indian political thought. The Dharma Shastras, a genre of Sanskrit texts, it outlined duties and responsibilities, dharma, of individuals within the social order, emphasizing the importance of justice and ethical conduct. But one thing we should remember, that Indian knowledge system has not developed in isolation. It has been influenced by and has influenced other cultures and regions through trade, conquests, and exchanges. The spread of Buddhism, for example, facilitated the exchange of ideas with East Asia. The Islamic Golden Age also saw significant intercultural exchanges with Indian texts on science and medicine being translated into Arabic and Persian. In contemporary times, there is a renewed interest in Indian knowledge system, both within India and globally. The meditation practices have gained international popularity for their holistic health benefits. Indian philosophical concepts are studied in academic institutions worldwide, contributing to global philosophical discourses. This knowledge system represents a unique synthesis of philosophical inquiry, scientific innovation, artistic expression, and spiritual wisdom. Its contributions have only shaped the Indian subcontinent, but have also influenced global thought and culture. The adaptability of this knowledge system, rooted in ancient traditions, yet continuously evolving, highlight its enduring relevance in the modern world. As Amrit already said, the new education policy 2020 recognizes this rich heritage of ancient and internal knowledge and thought as a guiding principle. The Indian knowledge systems comprise of Gyan, Vigyan, and Jivan Darshan that have evolved out of experience, observation, experimentation, and rigorous analysis. This tradition of validating and putting into practice has impacted our education, arts, science, administration, law, justice, health, manufacturing, and so on. It is obvious that since India is a country with a long surviving civilizational history and practice known to mankind, therefore it is not surprising that a rich repository of knowledge accumulated in the Indian subcontinent and manifested in terms of traditions and practices. This course is an effort to bring snippets of that Indian knowledge system by providing a fresh relook at the corpus and pulling out relevant portions that may generate renewed interest in the subject and motivate several to engage in a deeper study of knowledge repository of India. Lastly, Vasudhaiva Kutumbakam, the world is our family, is a beautiful concept that we often use. It's from Indian knowledge system. It emphasizes the idea that all beings are interconnected and should live in harmony, peace, and mutual responses. The emphasis on holistic understanding, integration of diverse disciplines, and the pursuit of knowledge for both practical and spiritual purposes remain the hallmarks of the Indian knowledge system. Thank you.
Thank you, madam. Thank you very much. It is now our immense pleasure to introduce Professor V. Ramanathan. We welcome you, sir, to our college. Dr. V. Ramanathan is a physical chemist working in the Department of Chemistry at IIT BHU Varanasi. Sir obtained his PhD in physical chemistry from IIT Kanpur, India. He carried out his postdoctoral research works in University of Stuttgart in Germany, University of Basel in Switzerland, and Seoul National University in South Korea. His areas of academic research are Raman imaging and spectroscopy, laser spectroscopy, and computational chemistry. His other research interest lies in studying the scientific heritage of India, Indian history, philosophy, and Indian traditional medicine. He is also interested in Indian and Indian languages. Sir is comfortable in 7 different Indian languages. He was a Fulbright scholar and a core committee member of Indian National Young Academy of Science, a body of Indian National Science Academy INSA. His other professional engagements are he is the chairman position paper on knowledge of India, NEP 2020, DSERT, Government of Karnataka. He is the member of National CAC for IKAS. He is the member of the Advisory Council and Board of Studies of Mohajogi Gorakhnath University, Gorakhpur, UP. He is also the member of Research Council for History of Science, Indian National Science Academy. He is also the member of Curriculum Development Committee of UGC in Indian Knowledge System. Apart from that, he is also the member of NET examination syllabus for IKS paper in UGC. He is also the chairman of UGC NET papers on Indian knowledge system. May I now invite our respected speaker, Dr. V. Ramanathan, to deliver his presentation. I would like to ask you about your health, sir. How are you feeling now?
I'm little okay, so I'll be able to give, not a problem.
Okay.
So, সবাইকে আমার নমস্কার এবং অভিনন্দন।
Thank you, sir.
আমি আমার সম্পূর্ণ ব্যাখ্যান বাংলায় দিতে চাই, কিন্তু বর্তমানে কিছু প্র্যাকটিস আমাকে চাই। সো তাই যদি আমি ভবিষ্যতে আপনার কলেজে আসবো, তবে আমি প্রয়ত্ন করব আমার সমস্ত ব্যাখ্যান বাংলায় ভবিষ্যতে আমি দিতে চাই। সো বর্তমানে আমি ইংলিশে সুইচ করব। So at the outset, I wholeheartedly express my thanks to the government General College Singur, and particularly to Dr. Amit Mitra, who has been in touch with me for several months to make this lecture happen. So particular word of thanks to you, Dr. Mitra, and all other office bearers of the college who have been in the forefront as well as in the backstage to conceive of such a very novel series of lecture. And it's not less than any privilege or honor for me to start this series. Since I'm giving it from my home, due to bandwidth issue, I will turn off my camera and I will turn it on when we have interaction session. I'll be speaking for about an hour, if that is okay with the organizers, and then we can have some interaction in the forms of question answer towards the end of it. So I will switch to my presentation, which will make me in-access the chat box. So if anybody wants to share any comment, I would request you to unmute and say it rather than typing it in the chat box. So much has been introduced, so I will skip. I'm particularly thankful to Professor Chaitali Chatterjee to have given a very broad overview of IKS, which makes my job quite simple. But the aspect that is perhaps left out while talking about IKS is, although it was touched upon the mathematics and astronomy and some amount of logic, but science part is what is left out. So hence this lecture that we have, where I'll be concentrating because I'm a student of science, I'll be concentrating more on the Indian aspects or aspects of science that was prevalent in ancient and medieval India. Again, for clarification, both the principal as well as Dr. Mitra used two different words. They said enrich and enlighten. I would like to beg your pardon. I am in no way that much knowledgeable to either enrich you all nor informed enough to enlighten you. We are all in the same journey of acquiring this newfound knowledge called Indian knowledge system. So I consider myself as a novice student in this area, and due to my good fortune, was associated with various bodies by which I could accelerate my learning in this field. So by no means this was going to enrich or enlighten. So I would like to state that very clear in the beginning itself. This is like I'm sharing what I have gathered over the past couple of years, some of which may be already known to you. And given the fact that Professor Choitali has given such a broad overview, I'm pretty sure many of the topics are already familiar to you, so you are already having some basic information. So with that disclaimer and a prelude, allow me to get into my topic, which is IQAC, broadly speaking, but I will be focusing more on science, little bit of maths, and of course, my own subject, chemistry, and thereby touching into metallurgy. But for the first 10 to 12 minutes, I would like to dwell on the universality of science and the approach to science vis-a-vis reductionist approach and holistic approach. And I would like to discuss this question: does Indian tradition harbor in itself any scientific temper? And why at all at this point of time in 21st century should we bother about science in ancient India? So with that prelude, with that introduction, I will be giving you some examples as a form of case studies, which will be clearer to you as I proceed. So this is a very famous portrayal by an artist, which is quite self-explanatory, where this is the Inquisition committee or the process of Inquisition happening for Galileo. Galileo had come up with certain theories about the nature which were completely antagonistic to the then prevailing beliefs in the society, primarily forwarded and perpetuated by the church. So he had to defend himself in front of the clergies of the church. And after that, what happened is history. But the point that I wish to drive attention is this kind of a clash that happens between believers and so-called newfound group of people who call themselves as rationalists. So this is a schism, and the end of this schism gave rise to what is called the Renaissance in the European geography, which had its impact on all walks of human endeavor, be it art, architecture, literature, music, science, philosophy. The Renaissance period, which was also witnessing this dichotomy and this friction, which in more occasions tended to give off heat than light, yet gave rise to a different field of, a different body of knowledge. Now, keep that as one aspect in your mind. And this schism is very beautifully summarized through this meme, where in science it is believed, or it is normally we attribute to science, that even when you have tons of evidence, doubt what you see. Whereas in the context of religion, and here I should be very careful in using the term religion, because this is not dharma. This is not dharma that we normally understand in the Indian context. Although the word religion is translated as dharma, but those two are poles apart. Here, religion is religion of book, confined to a specific geography, and don't get confused with the Indian context. So what is religion in that aspect? And even without a single piece of evidence, believe in what you can't see. So this is the essence of the clash that was happening between the so-called rationalists, who championed the cause of inquiry and thereby science, versus a group of thinkers who were firm in their belief, and they constituted the theologians or the religious people. Now, why I'm bringing this into in this inaugural address is that when science was getting imported in our country for the very first time through the labor of our son of soil, Acharya Rajaram Mohan Roy, in the early part of the 19th century, when he was trying to import the science, Western science, into the Indian geography, along with it, this clash that was happening between the two groups was also imported lock, stock, and barrel without applying a single piece of mind. Why I say this? Because as Professor Choitali also mentioned, right from the day one, when Indians started thinking and communicating, inquiry was at its core of it. It was never a dogmatic phenomenon or a practice that we had to ever witness. So much so that even one passage in the Rig Veda, if you look at the Nasadiya Sutta, it starts with a question. Where did this life come from? How did this earth get formed? So inquiry has been at its core. I mean, of course, inquiry has been at the core of every civilization, but some civilization adopted a dogmatic approach right after the inquiry phase. But fortunately for our case, our civilization continued with this inquiry-based approach, and so much so that, as all the three speakers before me, the principal, Dr. Mitra and Dr. Choitali, they emphasized enough on how we were obsessed about knowledge. We say knowledge, but have we ever wondered why the spelling of knowledge written in English starts with a K, even though the K is silent? It is because if you trace the etymological root of the word knowledge, it comes from gnos, G-N-O-S. And that if you go trace it further, it comes from the word jnana. And the word, the ucharana of the letter gya varies from place to place. I am from South India. I pronounce it as gya. But if you talk to anybody who is from Maharashtra or Gujarat, they will say it is jnana. Perhaps some part of Bengal also would say it as jnana or dhyana. D-N-Y-A-N or J-N-Y-A-N or G-Y-A-N. So this has been even the etymological root of the English word knowledge, and hence even to this day we continue the tradition of spelling of spelling this word starting with K sound, because it traces its root from the word which has originated in our culture. And that's why you have various quotations. I'm reminded of a quotation from Sanskrit. Adhamaha dhanamichanti, dhanamanautu madhyamaha, uttamaha manamichanti, manohi mahatam dhanam. Here the word mana is referring to knowledge. Right? So why I'm bringing this slide and having this discussion is to clearly show the difference between how intertwined the process of inquiry as well as seeking. We have always been seekers, has been our Indian culture. Vis-a-vis the European culture, these two had a lot of problems. And this problem did not get finished at any point of time. I mean, the same science versus religion is also philosophy versus religion. Questions may never be answered is philosophy, and answers that must never be questioned is religion. Now, for a moment, I leave it to you to think for yourself whether these are applicable to our Sharadarshana that Professor Chaitali was talking. We start with the Pramana. Pramana Shastra becomes the cornerstone, starting from Pratyaksha, and depending upon what school of system we follow, we either have 6 Pramanas or 5 or 4, or if you look at Charavaka, Lokayata, it has only Pratyaksha. Right? So, the fundamental difference to the inquiry, the process of seeking knowledge is entirely different. Epistemologically, we are completely different, and that grounding has to be properly understood before even we proceed to the body or corpus of Indian knowledge system. Later, when the European science as well as theology evolved, this, again a cartoon, shows a very good schism that got metamorphosed in 100 years. Like the creationist started saying the life on the earth as the evidence for creation, whereas the rationalists called this as an evidence for evolution. The Darwinian school as well as a creationist school. So again, this is a schism which is still ongoing. And if you look at the science field, remember, I don't know how many of you have got the science background, but 100 years, 120 years back, when quantum mechanics was getting newly proposed, probability was at its core. And it was again Einstein who was quoted in the introduction also. Einstein is very famous to have said, God does not play dice with human beings. It was not a direct literal reference to God, but to say that probability cannot dictate the future course of human beings. Because till then, the Newtonian mechanics, or what is called the determinism, was at its core of physics. Suddenly, when quantum mechanics comes in with its bogey of probability, even though Einstein was the father of quantum mechanics, it had some starting trouble for this concept to get accepted in the society. So there were several articles written, several books written, even to this day they are written, how to understand quantum mechanics. And thanks to the Nobel Prize given last year for entanglement, which somewhat brings this entire debate to a rest. So what I'm trying to say is, you see this epistemology of the Western civilization, it's an ongoing struggle, and epistemology of our soil is completely contrarian to it. I would like this point to get thoroughly grounded before we proceed further. And that's where we have this anthropocentric approach of the Western epistemology, which leads to ego, whereas you have a holistic approach towards trying to understand our surrounding or nature, which is what people have coined this term as ecocentric approach and not really anthropocentric approach. See, in our tradition also, I quoted Charavaka or Lokayata, and that was also an anthropocentric approach, because you had the very famous quotation, Yavat jivet, sukham jivet, rinam nitva ghatam pibet, bhasmi bhutasya dehasya, punaragamanam kutaha. So we had that anthropocentric Trick approach in our system, but it was never occupying the mainstream. It was always in the periphery. The mainstream approach was always ecocentric, where we never considered ourselves as the supreme or the pinnacle of creation, but we considered ourselves as a small, tiny part and part is we are a tiny part of this entire system. So much so that we said consciousness is pervading everything, whether it is alive or whether it is not alive. So this kind of a clear epistemological difference is seen through this approach, which the Western world is also now trying to come to agreement with it, because especially now when they're advancing in consciousness studies, they are again trying to look back towards Indian thing, starting from the lecture given by the effective lecture given by Swami Vivekananda almost 130 years back. Now I asked a question about scientific temper in ancient Indians, because if you recollect, right after the emergency period, there were several amendments made to the constitution. Besides the several groundbreaking amendments like introducing the term secular, there was also the directive principles of state policy. A line was introduced that every Indian should develop scientific temper. I mean, with due respect to the constitution and its makers, I have several objections to this on my personal level, because it gives a connotation as though Indians never had scientific temper. Now, this is a quotation that I'm showing to you from Shishya Dhivriddhira Tantra of Lalla, who in this text, in this chapter called Mithya Jnanadhikaraha, it contains about 80 verses. Okay, and as the name is signifying, as you all can follow, because Bengali is very close to Sanskrit, Mithya Jnanadhikaraha, Mithya Jnanasya Adhikaraha, the chapter dedicated to false knowledge or superstition. Mithya Jnana is false knowledge, and a chapter is dedicated for that. Why? He is not teaching false knowledge. He is trying to identify the false knowledge prevalent in the society and is trying to refute it. For instance, how are eclipses described in our society, be it north, south, east, west? It's always said as though some asura is coming and gobbling up, swallowing the sun or the moon. And depending on that, we have either the solar eclipse or the lunar eclipse, respectively. This is even to this day, this is how a story is being told so that every common man can understand what's going on. So Lalla says, Asuro, yadi mayaya yuto, niyatoti grasati iti te matam, gaditena katham salabhyate grahakrit parva vina kathanchana. So if I translate this roughly, it means, if really the demon is swallowing the sun and the moon, and if that is what you believe, then how come is it that I am able to mathematically calculate when this process is going on? He raises a question there. Gaditena katham salabhyate. How is it that possible I am able to obtain the correct time using my maths? Right? So one more he takes up, another Mithya Jnana. Where he says, Kamatha divi rudrita mahi yadite kena dhrita navasthita atagesham priyati sthitir yadi shitigolasya tu kena varyate. But this is coming from a Purana story again, that you have something called a tortoise, and on the tortoise this earth is being supported. Then the Puranic story also continues, and somebody asks, okay, if earth is supported by a tortoise, and what is this tortoise supported by? People will come and say elephant. Then how is the elephant supported by? See, it goes like an infinite regress. But here Allah says, if the earth is supported by a tortoise, then how are you able to accept the fact that the tortoise is just suspended? Yadite kena dhrita navasthita atagesham viyati sthitir yadi Kshiti Golasya tu Kera Varyate, then why can't you accept the fact that this sphere is also suspended just like how the tortoise is suspended? You don't need something to be beneath that sphere. You can as well assume that the sphere is still suspended. So now tell me, I mean, this is only 2 examples that I've given. A whole chapter of 80 verses are given like that, where each one is picked up and he's refuting it. I want you to guess. So I request Professor Mitra to coordinate this activity to see. I would like to ask a question and invite participants to answer roughly which period I'm talking about.
Sure.
Lalla or his book called Shishya Dhi Vriddhida Tantra. Please.
Dr. Shantanu Nath has raised her hands.
Yeah, please allow her to say.
Dr. Nath?
Or if anybody else is volunteering to say, I just want them to guess when this work was written.
Anyone from the audience? Anyone from the audience would like to interact?
Just to guess when this work would have got composed.
Okay, Miss Tritisha Mukherjee has raised her hands. Kindly unmute yourself, ma'am. Anyone from the audience would like to interact? Please unmute yourself.
Looks like they're either too shy or they are perhaps
maybe
still trying to contemplate what is going on. This text was written somewhere in 7th and 8th century, and he's from Kashmir. Lallacharya is from Kashmir. So now tell me, 7th and 8th century, when the Middle East was trying to capture the entire world, and when the Romans had already declined and they were trying to find settlement, here is our Indian guy of scientific temper. If this is not scientific temper, then what else is scientific temper? And very famous, you would have heard this, again a Sanskrit prayer. It says, Sahana vavatu sahanau bhunaktu sahaviryam karavavahi. And I'm sure you know this, the meaning is let us all learn together, let us all grow together. Can you believe who would have composed this? This is composed by a student. And this is told, a student is addressing the Guru and telling the Guru that now let us learn together. Why? Because the act of the interview was first conducted by a student. A student will have the liberty to go around the different Guru, interact with the Guru, conduct an interview of the Guru to see whether whether he will be capable enough to give me knowledge. So the student has complete liberty to question the Guru. And once he is convinced that this is the Guru that I would like to associate the rest of my student life, he will completely surrender. And it is at that occasion, when he is convinced, then he addresses the Guru and says, Sayana Vavatu. So if this is not scientific temper, then I fail to understand what else is scientific temper. So why to study about IQAC at this point of time in 21st century? I present before you 2 examples. One is from the western part of the country, Gujarat, which has Rani Ki Vav, a step well. And the second example is from the deep south, from my home state. This is near Tiruchirappalli, and this is a grand Anaikat, which was built 2000 years back. And the Rani Ki Vav was built at least 1000 years back. And they both are functional system even today for water conservation. But tell me, the population back then would be a fraction of what the population is today. Yet these people, the society back then, had the forethought, predict what would be the problem 1000 years later, 2000 years later. not only did they cognize the problem, they had also come up with a functional solution, which is there as testimony to their workmanship and forethought even to this day. Today, it's a challenge. This is a question that I want each one of you to think about and perhaps do introspection. Are we in a position today, with all our decorated degrees and achievements, are we in a position today to either individually or collectively to think about the problems that our future society would face, say, 500 years down the line, 1,000 years down the line, or 2,000 years down the line? What kind of problems will our society face? Are we in a position to come up with solutions? This is not a rhetoric question, and I'm not seeking any immediate answer right now. But this to me acts like a stimulus for us to know the brain of our ancient Indians, which worked in this magnanimous and wonderful way. And that's why such kind of workshop, lecture series, and NEPs laying stress on IKS. At least for this reason, let's look at what is IKS. So there are multiple approaches today with all our digital advancement. This is the way I look at approaching IKS. Either you can have a historical approach, you can have a text-based approach, or you can have a concept-based approach. In my slides that will follow, you will see a mix of all these three approaches in this very lecture. So, historical approach, since I am confining myself to chemistry, maths, and metallurgy, but this is a quotation that I'm giving you from Krishna Yajurveda, whose dating deliberately I put here, which is the mainstream dating given by Max Muller, and the rest of the historians have followed it, although this is very debatable and controversial, but I'll not get into that. But Vedic literature is considered to be by far the oldest literature, where we find explicit mention of 6 different metals: Hiranyan, Aya, Sisa, Trapu, Shyama, and Loha. And mind you, mentioning 6 explicit metals in one place is not a trivial task. Because remember, those of you who are from history background will see that the European scholars have divided the anthropological evolution into different ages: Paleolithic age, Mesolithic age, Neolithic age, then you have Copper age, Bronze age, then Iron age, and then currently whether we are in Silicon age or garbage, it is for anthropologists to decide. So there's a gradual evolution, and this is roughly every 500 years. Between copper comes first, then bronze, and then you have iron. But here we have, in one instance, where both copper and iron are mentioned at the same place. And the very fact that they have mentioned the metals and not their ore also signifies their knowledge, which is inherent about how to process these metals from their ore and how to convert them into usable forms. So that is from the Vedic corpus. You fast forward, this is about another text where you have description of gold. Jambunadam, Shatakumbham, Hatakam, Vainavam, Shringashuktijam, Jatarupam, Rasavidham, Akarodgatam, Cha Suvarnam. Then it goes on to say which is better, which is not good, so on and so forth. Again, I will pause here for a minute and invite your participation. Can you guess which text I am talking about? Am I audible?
Yes, sir. Yes.
So I'll just, again, to invite your participation, please give it a guess as to what text, because I'm pretty sure all of you have heard the name of this text at some point or the other. Okay, this is nothing but our very famous Arthashastra by Kautilya. The entire second Adhikarana is devoted for chemistry and metallurgy in this text called Arthashastra. Moving again fast forward, these are the places that, again, one of the very fine metallurgists that our country had produced, Dr. Panchanan Niyogi. Of course, he was from Calcutta, but most of his time he spent in Jamshedpur working. He was a founding personality of the NML, National Metallurgical Laboratory. He had written two brilliant monographs, one on iron and another one on copper. This was in the early years of the 20th century. So what I did is when I went through this monograph of iron by Niyogi, he has shown archaeological excavation of iron from different parts of country, which have shown as arrow marks. So you have all the way from Delhi in the north to Tirunelveli in the south, and you have Somnath, Dwarka in the west, Puri in the east. But the beauty or the wonderful point is that all of them had got similar iron artifact. The composition of iron was similar across the different geography. This is only possible if the knowledge of iron metallurgy was pan-Indic, or iron was processed centrally and it was taken to different places. So what I wish to convey here is that pan-Indic knowledge is what is more appealing, which means even though they were connected, they were not connected easily because of vast geography, still the knowledge was quite pan-Indic. That is something for even now, even historians can do this research and come about with establishing this knowledge continuity. Of course, iron pillar, everybody knows. I will not bother describing again about it. And this is the famous Damascus sword. Damascus is a place in Syria where Indians were taken as captives who had the skill of making what is called a Woods steel, WOOTZ. Again, Woods is an anglicized way of pronouncing the Indian word ukku. Ukku comes from my native language, Tamil, which is called the urukku. Urukku means to melt, and urukku gets transformed to ukku. Ukku becomes woods in English, and this had a very peculiar property that it could retain the sharpness of the sword even after killing several heads in the battlefield. It was light in weight, it was quite durable, robust, flexible, all the properties that you want an ideal sword to have, this wood steel had it. And it had such great demand that when Alexander interacted, there was an encounter between Alexander and King Puru. Here, there's a beautiful artist's imagination, which is hanging not very far from where you are, Singur. This is in a place called Ranchi in Jharkhand, in the Steel Authority of India Limited's head office. Alexander is shown in the golden dress, and Puru is shown in the black gown, and he's presenting this Damascus sword to the Alexander. And behind Puru, his servant is standing with a golden box, and look at the positioning of his hand. There is something, it is indicative of something being inside, which Puru has either just showed to Alexander or is about to show. What is there inside the box? It is a steel brick. So a steel brick is gifted to Alexander by keeping it inside a gold box. Imagine the times that were almost 2000 years ago. Today, imagine what economic low level we have fallen to. Even if we buy a gram of gold today in the form of any ornament, we would immediately run to the bank to keep it inside a safe locker made out of iron. And back then, a steel brick is gifted to a state delegate by keeping that steel brick inside a golden box. Anyway, the other metal which I would like to well, a little deeper, is zinc. Now, zinc has got a very lofty history, and Indians were truly the champions to have smelted this metal for the first time in the entire world and to have done it to perfection. But there are enough scopes of research in this, because the text, what it says, and the archaeological excavation that we have got, there is no link. So much so that the Sanskrit text and the English translation offered by Acharya Prafulla Chandra Ray is also not accurate. So there are a lot of such scopes of research even now currently to properly understand this process. Based on what P.C. Ray had done, this is what the process is described, and which is a remarkable invention, indigenous invention. I'll not get into the details. And for the first time, Indians were successful in producing pure zinc. And look at this. This is an excerpt that I've quoted from Sui Shu, or the Book of Sui, and from the Sui dynasty, which lasted in the 6th century AD in China. What do they say? They explicitly offer wholehearted acknowledgement to Indians for the art of making zinc. They clearly say Tianzu is an Indian word in Chinese, and they say that all these techniques were transmitted from India. But you see, the sad part of our curriculum, scholastic curriculum, be it in the school or in the college, our own Indian traditions are not being properly given due justice. So that's why ADP has put it in very clear terms, and you are having such sensitizing workshops to talk about such topics. In the context of zinc, I must also mention that the metal which I did not talk about is copper. That was also a very remarkable metal in the Indian history. And alloys of copper, namely brass and bronze, are two important alloys of copper. And brass has got its antiquity from a very early period. So, for instance, this is Karkayana Shrauta Sutra, which is roughly dated to 600 BC or later. He talks about brass. And in the context of brass, it is very important to realize that there are two types of brasses. One is intentional brass and one is accidental brass. And I'm not getting into details. For intentional brass, you need to have pure zinc and mix it with pure copper. Then only you can get intentional brass. Simply put, brass in which the zinc percentage is less than 15 is accidental brass. And brass in which the percentage of zinc is more than 15%, it is intentional brass. And there are very good research articles which have categorically proved that it were Indians who had made intentional brass for the first time, and thereby we can conclude that Indians were the first to make even pure zinc. And bronze, of course, everybody knows, because this is there in the textbook, that right from the dancing girl of Harappan age to the Chola bronze which are made even today, in a place called Swamimalai in Tanjavur, the art of making bronze, which is an alloy of copper and tin, is very much in vogue. Okay, so, but here is one point that I wish to clearly underline and draw your attention to. I am not at all claiming that our ancestors knew the language of phase diagram, and the phase diagram is what I'm showing to you in front of you, where it is either for copper with zinc or zinc with lead. Okay. Today, in the modern engineering, we learn how to make alloys with the help of phase diagram. But back then, they did not reveal to us how they had acquired this knowledge. Rather, what we have today is the fact that they knew how to make alloys. When I say they, I meant our ancestors. They knew how to make alloys, but it is absolutely not clear to us how did they make these alloys. Okay, it is for us to invest more of our research in that direction to unravel how they made it. They made it serendipitously, they made it accidentally, that part is good, but the fact is they made it. At least archaeology is there to prove to us. But so point here is, please don't over-exaggerate our ancient Indian contribution by saying ancient Indians invented phase diagram. Absolutely no. In the context of zinc, Paul Craddock from again Britain, he had done extensive work, and he had this to say that this is the earliest dated zinc mines in the world, which are the Chavarmala mines near Udaipur in Rajasthan, and they are the earliest known center for zinc production on an industrial scale. Textual examples I'll quickly fast forward due to want of time. This is from the Rasarnava. Now, Rasarnava in Bengal, it was widely researched by the Kobiraj communities because Indian chemistry was a pragmatically oriented chemistry, and the first application of Indian chemistry was in medicine. So in that context, Rasarnava was a text deeply researched by several Kobiraj in Bengal region. So much so that this is that. See, procedures were described for making metal from Akshika and Vimala and Shashyaka, the first two being pyrites bearing copper and the third copper sulfate. And the wonderful observation was made that all the three red products seemed to be identical, tamra or copper. And this is more important what he had to say. This observation made centuries before the discovery of elements and Daltonian chemistry cannot be belittled. See, this paper was published way back in 1980s. Okay, our textbooks never talk about such things. Not 80s. This was published in 2000, 2001 to be precise. But still, a textbook does not talk about all these things. This is a very famous quotation which I always like to show, again from Rasarnava, which is the first ever documentation of what the chemistry people do in lab called a flame test, introducing different metals and metal salts and see the change in the color of the flame. This avartamane kanake pita tare sita prabha shudve neelanibha tikshne krishnavarna sureshwari. So you have metals and the colors. Kanaka gold, pita yellow, tara silver, sita is white. Shulve copper, neela dark. Tikshna is iron, Krishna is again black. Vanga, Sureshwari is a dialogue form because the entire Rasarnava is written in a dialogue form between Shiva and Parvati. So that's why here and there you see references to the Parvati or the counterpart, the two people who are having dialogues. And they give very precise qualitative checks to see whether the process is complete or not. So I will. And they have even done a quantitative study by arranging metals in the order of their reactivity to sulfur. Suvarnam, Rajatam, Tamram, Tikshnam, Mangam, Bhujangamam, Lohantu, Shadvidham, Tacha, Yatha, Purvam, Tad, Akshayam. So the gold is the most stable, followed by silver, followed by copper, iron, tin, lead. There's a slide. So this is the sequence that they have arranged. So you have another text called Rasaratna Samuchaya, which is a slightly later text. Mind you, here is one important point that I wish to also make. Perhaps India can go and file a Guinness Book of World Record to have the maximum number of texts which are undated. That is category 1. Second category, number of texts whose author is unknown. Category 3, a text having a date range of more than 1200 years. For instance, Rasarnava, which I showed you before, there was one Kobiraj called Bhudev Mukherjee in Calcutta. He dates Rasarnava 300 BC, whereas PC Day dates it to 800 to 1200 AD. So see, one text having such a vast dating range. So perhaps India should go to Guinness Book of World Record for filing such bizarre features. So Rasartha Samuchaya also is said to be between 10th and 12th century, and it describes various processes that are even currently practiced in the modern chemistry lab, like how a lab should be designed, where should the volatiles be kept, how should the ventilation be, where should highly reactive substances should be kept, so on and so forth. Describes about various furnaces, Mahaputa, Gajaputa, Varahaputa. So you may wonder why this kind of nomenclature. Definitely, we did not have thermometer back then to measure the heat that was imparted. At least I have not come across any quantitative estimation of heat back then. Thermometer definitely an invention by the Europeans, to the best of my knowledge. But back then they knew that in order to melt iron, they needed more heat vis-a-vis melting, say, zinc. So how did they achieve this? They achieved it by changing the fuel content. And how did they change the fuel content? They specified the dimension of the furnace. So as the name itself implies, you have Mahaputa, Gajaputa, Varahaputa. Varaha is pig, Gaja is elephant. So that itself gives you the name, which will be bigger, which will be smaller. Then you have Kapota Puta. Kapota is a pigeon. So it's a very small. Kukuta Puta. Kukut is a dog. So so on and so forth. Then you have this kind of distillation apparatus which are still in vogue, which is called Tiryak Patana Yantra. And even to this day, the prototypes, which is shown in the picture here, are scaled up and used exactly as they were described in the text some thousands of years back. This is from a place called Kannauj, which is called the perfume capital of our country, where this apparatus is extensively used to extract perfumeries. This is from Brihat Samhita. This section of my talk is about text-based approach. So I showed you three texts, Rasarnava, Rasaratna Samuchaya. This is the Brihat Samhita, written around 4th to 6th century by Varaha Mihira, which is not just an astronomical text, which is an encyclopedia of multiple subject. But very interestingly here, if those of you can follow Sanskrit, the first line will give you the clue what it is about. Srik Gandha Dhupambara Bhushanadhyam Nashobhate Shukla Shiroruhasya Nashobhate Shukla Shiroruhasya. It is talking about white hair, whitening of hair, which is even a problem today. So back then, the beauty standards did not permit a king to have white hair. So it had to, they had to come up with dyeing the white hair. And what follows is a recipe to prepare a dye so that this Shukla Shiroruha would become Krishna. I mean, why I'm showing this is even now if somebody takes it up, it has got commercial interest. And this is completely organic. There is nothing like you have chemicals that are being used. If you look at the content, everything that is available in nature is what is used. So it has got, dwelling into IKS is not just a tour in history. Even it has got commercial ramifications as well. So there are different ways to, put the same Brihat Samhita. You have this description of perfumeries. Now, I would like to pay close attention to three things here. The Shloka 20. Shodashake dravyagane chaturvikalpena vidyamananam ashtadasha jayante shatani sahitani vishantya. What it says is, if I have 16 different base perfumes and I'm allowed to choose any 4 of them at random to make my final perfume, how many such perfumes can be made? Today, those of you who remember maths or the formula of permutation combination, this is actually NCR, whose formula is n factorial by r factorial into n minus r factorial. So here n is 16, r is 4. So it is 16C4. which you compute, it will come down to 1820. Today we use this modern mathematical notation called 16C4, but in the Brihat Samhita back almost 1500 years back, how this is given? This is given in the shloka number 22. Purvena purvena gatena yuktam sthanam vinantyam pravadanti sankhya ichha vikalpaihi kamashobhiniya nite nivritti punaranya nitihi. I will not bother to translate, but I'll show you the pictorially. What it says, Purvena Purvena Gatena Yuktam Sthanam Vinantya Pravadanti Sankhya. So what it says, suppose you have 16 starting point, you write the numbers from the bottom to the top. Purvena Purvena Gatena Yuktam. Okay. Then what it says, Sthanam Vinantya Pravadanti Sankhya. What it says, again, it starts for second row now. It starts with 1. Now, the second entry will be 1 and the second entry of the previous column, which is 3. So now the next entry for this column will be this entry and the third entry of the previous column. So 3 plus 3 equal to 6. 6 plus 4 equal to 10. Then what it says, Ichha vikalpaihi kramashobhiniya. So what is our Ichha here? 4. So do this process until you are having 4 columns. So whatever is the last number, it says Kramashobhiniya nite nivrittihi punaranya nitihi. So whatever this nivritti comes after the Ichha vikalpaihi, that is your number, desired number, 1820. See, such a very elegant way to compute NCR. I mean, using the same, this is a Gandhayukti chapter of Brihat Samhita, you have multiple magic triangles, which are called, not triangles, sorry, magic squares, which have got several in Sarvato Bhadra. I mean, magic squares are those, like if you add the numbers which are horizontal or vertical, they will all add up to the same number. It all again comes from the Gandhayukti, that these are the base perfumes. Agara, Patra, Turushka, Shailaya, Priyangu, like that you have different base perfumes. And then this is actually a recipe to make perfumes. But as a collateral advantage, you also have this mathematical detour giving you magic squares. I mean, which is what is NEP also talking about, cross-disciplinary approach. So in the same spirit of cross-disciplinary approach, and I'm sure Bengalis are also very famous of poem, like all other Indians, and Chanda becomes a core of our Indian poetry. Okay, I'll not dwell deeper, but I will give you a very small example of how mathematics emerges from poetry. I'm sure all of you will know what Hars, Laghu and Guru Aksharas are. So here Kula Vadhu, Ku is a Harsvakshara and hence a Laghu. But in Kumbhakarna, there is a rule that even though Ku is a Choti U ki matra, but because it is followed by a Samyukta Akshara, this Harsva becomes actually a Guru. So, to take an example, I was searching for a Bengali example, but I could not get, so please bear with me to have this Hindi or a Bhojpuri example, which by the way is also not very different, because when Kavi Kokila Vidyapati was writing, that's how Bengali also evolved. He is considered as a father of even Bangla, Kavi Kokila Vidyapati. It is a matter of, again, a very misfortune that current day school going, even Bengali kids or even people who come from Mithila region of Darbhanga and Bihar, they are also not very much, they are not at all aware of who Kavi Kokila Vidyapati was. So this is also not very different. This is one of the old grand relative of Bengali, that is your Bhojpuri. So Jai Hanumana Gyana Gunasagar. If you look at Jai is a Laghu, Ya is a Laghu, Ha is a Laghu, Nu is a Laghu, Ma is a Guru. So if you add up everything, it will add up to 4 plus 2, 6, 6 plus 3, 9, 9 plus 3, 12, 12, 14, 16. each line will add up to 16. If you give 2 to Guru and 1 to Laghu. Okay. But what you see here, the positioning of Laghu and Guru are random. So the Chandakara asks a question that having fixed the total number, how many ways can I achieve the arrangement of Laghus and Gurus? Right? So this is what is summarized in this table. This numeric value is what the total value that we fix. For instance, here the numeric value is fixed 13, whereas in this Hanuman Chalisa, the numeric value is fixed as 16. So it asks if the numeric value is 3, how many different ways can we achieve this 3? I can have 3 Laghus, or 1 Laghu followed by a Guru, or a Guru followed by a Laghu. There are 3 different ways. Similarly, if I have 5, my numeric value is fixed to be 5. How many ways can I achieve this 5? I can have 5 Laghus, 3 Laghus and 1 Guru, 1 Guru and 3 Laghus, so on and so forth. Like that, I can have 8 different ways. Okay. Now, again, I will take a pause for a minute and invite your participation. Do you see any pattern in this last column? Which also makes me ask Professor Mitra, how much more time do I have?
Sir, you can continue for 20 minutes.
Okay.
20 to 25
Okay,
minutes.
good. So, would anybody in the audience like to take a guess if you see any pattern that is emerging in this last column?
I think it's Fibonacci series.
You're spot on. Exactly. But you see, thank you for that reply. Today we refer to it as Fibonacci series. Our Indian textbook also call it as Fibonacci series. But this was enumerated by our Chandakara several centuries before even Fibonacci was born. In the context of composing poetry by helping him to position Laghus and Gurus given a fixed matra. Now, I leave it to you to decide how shameful it is for us Indians to not even recognize this sequence by an Indian name, which had originated in our own country, but we now give it a credit to a European. I'm not disrespecting the European here at all. We are from a civilization where Ano Bhadra Kritavo Yantu Sarvataha. We take knowledge from everywhere. But here, historically, this sequence was established several centuries before Fibonacci was born. Okay, so the last segment of my talk, which is a concept-based, which is quite relevant even for today, this is to do with the traditional medicinal system of our country. And one such medicinal system is the Siddha medicinal system from the southern part of our country. Just a sec. So without getting into the minor details, I will, in both in Siddha and Ayurveda, you have 3 different strategies of therapeutics. One is called Manusha, then you have Deva, and then you have Asura. So what is Manusha? Suppose I'm having cold and simple fever. I will make some kadha at home and prepare and drink it. If my fever or cold does not subside, then I have to go to a doctor, and then the Vaidya or a Kobiraj would exercise something called a Deva Aushadhi, which are completely metals and minerals in origin. Okay. So Siddha medicine today has got a lot of such metals and minerals, and Ayurveda, due to several controversy, has stopped extensively prescribing or using metal-based drugs. But I must tell you, I'm a survivor of COVID, where I had temperatures close to 104, more than 104 for several days, but I did not take one paracetamol also. I take traditional medicine only, and the medicine that I took was mercury-based medicine, which is supposed to be toxic. Even now, I am taking mercury-based medicine. So because of such controversy that WHO limit these medicines are 1,000 times more than WHO safe limit of mercury. That's why world had taken a different ban on this metal-based drugs, and Ayurveda community in some places blindly followed it. But here I am sitting live with all my energy and conversing with you. So what I wanted to show you here was how the ore was purified. There is a distinct step of purifying the ore. And then once the ore is purified, it needs to be triturated and is mixed with several herbs. So if you mix with these herbs, you get something called Kanta Chendura. And if you mix with only this herb, that is your fig tree latex, you get Kanta Bhasma. So then after this trituration, what is followed is called applying the heat calcination process. And then we measured and then we characterized at the end. What do we make at the final end of this process through all these contemporary techniques? And then we concluded that herbs play a vital role in the physico-chemical transformation of raw materials to drug formulation. So there's a core shell nanoparticle that is getting formed of iron oxide as a core and silicon oxide as the shell. And I'll not get into the details. Those of you interested, this paper is published and available in the literature. There are various such examples from biology, where even the simple word conveys a lot of meaning. The word Hridaya comes from two different words, Hr and the, three different letters, sorry, Hr, the, and Ya. Hr comes from Harati, which means to receive. Da is the short form of Dadati, which is to give. And Ya stands for Ayati, which means to go, to move, or to circulate. That which receives and gives blood and makes circulation happens, that is Hridaya. So the Sanskrit definition of it is given in this accompanying Devanagari text. What I'm saying here is, the very word itself is giving you the entire function of that particular organ. How remarkable this is, right? Then you have process of the blood purification, blood circulation, the activity of respiration are described in a very, very poetic way. Nabhistha pranapavanah sprashtva hrit kamalantaram kanthadir kanthad bahir viniryati patum vishnupadamritam. Now people have wrongly translated this Vishnupadamritam actually. So this has got to do with pranapavanaha is oxygen. Vishnupadamritam is it comes to the apex of our the windpipe. Pitva chambara piyusham punarayati vegataha. It's the entire process of oxygen getting inside the blood and the blood coming out with non-required gases is very poetically described in this text of Bhela Samhita. Okay. Now, my last few slides, I'll stop with it. William Ramsay, the Nobel laureate, had this to say, that whichever country is advanced in the rest of the world in chemistry will also be foremost in wealth and general prosperity. And his words are indeed true. If you look at this economic analysis of 2000 years of GDP by Angus Madison, this paper was published in 2003, 2004, not 3, where he had analyzed the GDP and contributions of each country to the world GDP. And if you see here, India and China had dominated the world contribution to the world GDP for mostly 1.7 millennia, right? But there's a steady decline in the India because you know what happened in the history, right? From Alexander, you had several invaders, one after the other. Then you had people who came for trade, East India Company, then they colonized it, and today we are somewhere here. At least through my presentation, I would have given you an impression that we would have been extremely smart in processing materials, metals, and chemicals, because of which we had this economic prosperity as predicted by this Nobel laureate. Okay, all is well, then where did we go wrong? If we had that kind of a promise, if we could contribute to the third of a world GDP, why are we not having the same thing today? There are several problems. We are not shying away from our problem. But what is more important, as a take-home message, I beg to inform you that every problem will have multiple reasons and consequences. One cannot generalize the problem. Like one generalization, what historians of science has done it, because this is in our ancient knowledge has been in Sanskrit, and because Sanskrit is confined to a special elite class, it was not mass propagated. That is definitely not correct. Which means to say, yes, there were problems, but one has to really do, with all academic rigor, analyze the problem. I wish to communicate this in a very, very lighter vein through a joke by this animation that you had a scientist who was experimenting with frog. What he did, he cut one leg of the frog and asked the frog to jump. The frog had 3 legs and the frog jumped. Then again, the scientist cut another leg. So the frog had 2 legs, but again, the scientist said, jump, and the frog jumped. And like that, one by one, the scientist cut all the 4 legs. Now, when all the 4 legs are cut, the scientist asked the frog to jump, and the frog obviously did not jump. What did the scientist conclude? That when all the 4 legs of a frog are cut, the frog becomes deaf. This kind of a simplistic conclusion arrived for a complex problem has been the pet peeve of a section of historians of our country, and specifically also historians of science, which is a very sorry state of affairs, which we need to collectively dwell deeper into it, and then we need to come out with solutions, and whereby we can look at, somebody said, Dr. Mitra only said it in the beginning, we can have a glorious tomorrow. Where C.V. Raman was invited to Cambridge by Rutherford, C.V. Raman felt very disappointed. He said, it seems to me Cambridge is a place for play and not for study. Why? Because when C.V. Raman was touring around Cambridge, he found people dancing, singing, doing carpentry, metalsmithy, everything. Immediately Rutherford said to C.V. Raman that we do not try to grow bookworms here. We train men who can govern an empire. So with that hope that we will see the glorious tomorrow by our impressionable minds turning out to be capable of governing empire, I once again thank you all for giving me this wonderful opportunity. I think I've taken extra time. If so, please bear with me, and I'll be happy to interact with you if you have any question. Namaskar.
Namaskar, sir. Thank you for inspiring us in such a wonderful way. It seems whatever time you have been given is not enough, because your presentation was so enthralling that we would want to keep listening to you. Thank you very much, sir. Thank you very much. Now this particular forum is open to questions. Participants who wish to present their questions to the speaker may do so by typing them in the chat section, or they can directly unmute themselves and ask questions to Professor Ramanathan. By the way, what about your health, sir? Are you feeling okay? Okay. Dr. Priya Banerjee has raised her hand. May I request Dr. Banerjee to unmute yourself and ask question to Professor Ramanathan?
Good afternoon to all the participants of the event and the speaker. I'd like to say that I'm well impressed by the presentation. I did hear the questions you were addressing the audience. I could not participate much because I did not know the answers. So that's why I did not answer you. So my question is, since Indian knowledge system is becoming an integral part of our education system and it's strongly emphasized upon in the NEP, so you have given us a very comprehensive idea and it was a very detailed presentation. It gave us a lot of enlightenment regarding things we are unaware of. But for a student or for an individual who wishes to gather more knowledge, where do we get the information from? Because the scripts and the texts are, even if they're available, they are incomprehensible by us. So is there any kind of text or book available right now which we can refer to while we are while we study, rather, I'd like to say?
I'm with you, Dr. Priya, that we have dearth of materials. I would say, partly I will agree with you. We have dearth of ready-made materials because today we are a generation of, fast food, 2 minutes Maggie, whatnot. There are literature available, but they are in niche level. For instance, if you look at history, Yadunath Sarkar and R.C. Majumdar, they have, although they are primarily historians, they have done a lot on history of science also. I mean, there are several names that come to my mind. A.K. Bagh, then A.K. Vishwas, this Beena Chatterjee, whom I showed, of Shishyadev Vrdhita Tantra. Bhudev Mukherjee's 2 volumes, Acharya Prafulla Chandra Rai for chemistry. On top of that, Acharya Brijendranath Sheel, the philosopher of science. I can go on rattling names. It is not to show off that, okay, I know these names. What I'm trying to say is, we have information written by all these people in English who have looked at the primary text. So today we do not have them ready-made under one compilation. That is where our effort has to be put in. We need some effort, and since I know that I'm addressing teachers here, I try to pitch it in that level so that you may get interested in a particular topic and you may try to go search deeper and you will receive it in a different way and you will present it to your student in a different way. Ultimately, I believe teaching is different from coaching, and both teaching and coaching are different from a job of a postman. We are not here to convey information from one textbook to the other textbook. Right? So, especially topics like these, unless I am internally fired up to have this thirst for knowing this, no amount of compulsory, mandatory attendance, no amount of asking people to attend workshop and conference is going to help. This is one such field where unless I have an interest, I will not be in a position to advance further. It will do injustice to the entire field. I know I have answered your question in a very, very circuitous manner, but as I said, I partly agree with you. We do not have ready-made materials on it, but we do have enough materials in bit scattered everywhere. That's how I would like to put it.
Thank you, sir. Anyone from audience would like to ask question to Professor Ramanathan?
Need not be just questions. As I said, we are all journeying through in the similar manner. If you have some suggestion, if you have some critique, most welcome. I mean, I would be the one to benefit from your labor.
Definitely, sir. Anyone else? I saw one hand raised from Miss Namita Jaiswal. Are you still there, ma'am? Any question from our participants?
And regarding this material, what I can at least do, what the least I can do is I can share my presentation with Professor Mitra, and if Professor Mitra can feel free to share it with whomever you want, or whomever approaches. Like one of my professors used to say, we don't believe in copyright, we believe in right to copy. Whatever
Yes.
I have made in my presentation, it's not my original thing. I have also copied it from several places. So I have absolutely no qualms. I will share it with Professor Mitra, and anybody interested can approach him to get it from.
Definitely, sir. Thank you very much. Sir, I think that no more questions are there. Anyone else from the participants? Okay, so no questions are there. Actually, our speaker is so eloquent and mesmerizing that we do not want to let him go. It is always a great experience to listen to you, sir. My heartfelt regards to you. I'm requesting all the participants to fill in the feedback form posted in the chat box. Kindly note that the second lecture of this particular workshop is scheduled for 28th May at 6 p.m. IST. Resource person is Ms. Amrita Dashgupta, doctoral candidate from School of Oriental and African Studies, London. Now, the most important part of any webinar or seminar or conference, that is the vote of thanks. So I would like to thank Professor Shantanu Chakraborty, the respected principal of Government General Degree College, Singur, Professor Choitali Chaudhuri, coordinator IQAC, Government General Degree College, Singur, and all the respected faculty members of these institutions and from other colleges across the country for their continuous support and guidance. I also extend my heartfelt gratitude to Professor Shoikat Bandyopadhyay and Professor Anupam Sen for their indefatigable spirit of inspiration and sustenance. Last but not the least, my wishes of sincerest gratitude go out to Professor Ramanathan sir for being kind enough to grace this occasion with his magnanimous presence and sharing with us his vast repertoire of knowledge. Thank you very much, sir. It will be our pleasure to meet you in person in future. Please let me know if you have any plan to come to Kolkata.
Sure. Thank you very much, and namaskar.
Thank you, sir.
Goodbye.
Thank you, sir.